Welcome to day 3 of Math for Today. So here we are. We're going to look at the question that has two parts. First, we're going to answer part 1 and then part 2. So let's take a look here at part 1. What's it asking us to do? It says, which figure has a volume of 1 cubic unit? So we've been working on area. We know that area equals length times width. And that's pretty much like a square, and we're measuring the surface or the face of the object, kind of like Flat Stanley, right? He doesn't have any dimension, he's flat. And this is area, this is what we're measuring here. We're measuring the length and the width. So there's no dimension, it's just the two, the 1, 2, Flat Stanley. This is kind of how I remember area. And then volume, we're gonna measure 3 dimensions, length times width times height. And that's what you know, and you see here, this shape here, how much space it takes up, how much you can fill up in this space. That's your volume. So there you're going to see there's 3 dimensions, 1, 2, 3, and that's why we call it a cubic unit. So we're going to find out which one equals 1. I'm going to do some elimination here really fast. If I look here, I know that if I multiply this decimal 0.01 times 0.01, I'm going to move these decimals out of the way 1, 2 times on this number. And then I moved out the place value over here 1, 2 times. Okay. And so that's a total of four place values that I moved that decimal over. Then I'm going to do this regular standard algorithm, which is 1 times 1, which is 1. And I know the rest is going to equal 0 because 0 times anything is going to be 0. So I have to put the decimal back. So if I moved it over 4 times in total, I have to move the decimal over back 4 times. 1, 2, 3, 4. So there's my 1, 2, 3 decimal here. So I have tenths, hundredths, thousandths, 10 thousandths, and this is a fractional part. It's definitely not 1. So we know it's not this unit. And then I'm going to multiply it. Let's try this one. Let's try 0.1 times 0.1. We're just measuring the length and the width first. And let's just kind of see, that'll give us the answer right away. We didn't even need to measure the height on this one. So 1, the length times the width. Moving that decimal over again, 1, 2. So this is a total of 2 times we move the place value. So 1 times 1 is 1. I got to put the decimal back, move it over 2 times, 1, 2. This is 100. So this is definitely smaller than 1 cubic unit. It's not this one. And then I'm going to multiply the volume here. Remember, length times width times height. So this is the length, 1/3. This is the width, 1/3, and the height, 1/3. So 1 times 1 times 1 is, 1. And then 3 times 3 is 9, times 3 is 27. 127, definitely not 1. Okay, and now here I'm seeing the unit 1 times 1 times 1, 1 times 1 times 1. That is going to give me 1. And then you could say cubic unit because we multiplied 3 dimensions, length times width times height. So this shape is definitely the 1 cubic unit. So we're moving over to number 2. This is part 2 of the question. When you're using a figure with 1 cubic unit, and I'm going to bring out my little trick here. This is kind of like a little cube. It's a sugar cube. And I love these. Don't lick them. If you have them at home, hold on to them. But this is 1 cube, right? 1 cubic unit. We could say that this is 1 unit, 1 length unit, 1 width unit, and 1 height of unit. So I have one of these. So Max arranges 16 of them side by side. Guess how many sugar cubes I'm going to measure and put together? I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. I'm going to turn it this way so you can see them all coming in. 12, 13, 14, 15, 16. How many cubes did he use? You can see right there. There's the answer. You know which one to pick. Okay, that's problem 2. So let's go on to problem 3. This is the power of knowing all the parts of your fraction and what they do. So Evan, he went on a spending spree. He spent 1/4 of his money on clothes and 1/6 of his money on food. Which model shows what fraction of his money Evan had left over? So this is telling us it's a leftover. We're going to be subtracting, but we're not going to be subtracting 1/4 from 1/6, right? We have to subtract it from how much total money he had, but how much money did he have? Well, let's figure out remember the numerator tells us the parts that we're counting. The denominator tells us the total part of the whole. So let's see if we could find out what common denominator they have and use that. That's going to help us see which model we can use. So let's find out how many parts we can make these in common. So let's see, I'm going to make a T-chart. And I'm going to remember that we're going to try to get them the same 4 and 6. So those are my denominators. They tell us in this shape, this has 6 total holes. In this shape, it has 4 total holes. So we could represent it like this. That's 1/4. And we can do the same here. This one, we can represent it. There's just 6 parts. I think I made 9 parts. Yikes. Okay, let's take that one out. Boom, boom, boom. And then you just have 1. So that's 1/6 and 1/4. So in order for us to compare them, we have to make them have the same amount of parts. So this is our T-chart. This is going to help us know how to split up this whole before we start. So 4 times 1 is 4. 4 times 2 is 8. 4 times 3 is 12. And so I'm going to stop there because I know that 6 times 1 is 6 and 6 times 2 is 12. So here we go. We're going to turn these into having the same denominator. So 1/4 is going to be equivalent to, we're going to turn this into an equivalent fraction. Equivalent means it looks different, but it is the same. Well, you'll see right now. 4 times 3 gave me 12. So whatever I do to one side, I have to do to the other. So it's 1 times 3 is going to be 3. So this 1/4 is equivalent to 3/12. Okay. Now I'm going to do the same thing with 1/6. 1/6 is going to be equivalent to, I use 6 times 1, 2 to get 12. Whatever I do to the denominator, I have to do to the numerator. I said denominator, 1 times 2 is 2. So I have 2/12. So this is 2 parts out of the 12. All right. So I'm going to look here in the models. And so this is telling me that the whole amount of money that Evan had first was 12 out of 12. All right. So I'm going to look down here. I'm going to see which shape starts off with 12 out of 12. So I know there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. This has 12 parts. Okay. So this one might be a good model. This also has 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. This one might be a good model. And if I come down here and I see there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 parts. This one's not it. And this one's not it because the denominator tells us there's going to be 12 parts of this money. All right. So now let's find out what happens here. So the first thing we know, Evan starts off with 12/12 money. Okay. So this one, we'll start here. And then he spends 3/12 of it. Oh, look at here. 1, 2, 3. This 3/12 is gone out of here. So, this one's looking like a strong contender, right? He subtracted that. And then, so now let's look here. 2/12. Oh, look at here. 3/12 was already spent. And then this is 2/12. This is definitely looking like a contender. Okay. So 2/12 out of there. And then we're going to check it. Oops, not 2/12. I'm trying to go crazy here with these. All right. So now, here's how we can test it. Here's how we can test it. Let's take out 12/12. Let's subtract 3/12. That gives me 12, take away 3, gives me 9/12. Okay. And let's take away the 2/12 from the 9/12. That gives me 7/12. So let's check to see what's left over of his money. 1, 2, 3, 4, 5, 6, 7. Oh, 7 out of how many? 8, 9, 10, 11, 12. Here we go. We didn't even need to go far. This is the model. Wow, this was fun. This is why you need to know all the parts of the fraction and what they do. Oh, and I love making models. I know, it's so fun. Okay, here we go. Oh, volume. What was our equation to find the volume? Remember, we're trying to find out how much space gets taken up in this shape. And volume equals length times width times height. And so the length we know is the longest one is going to be 8. The width goes from here to here. That's times 2. And the height is going to equal 5 centimeters. Okay. And so we're going to leave the units right here just for a minute so we can time these. So what I love about multiplication, when you have numbers like this, all of them are multiplying, You can make friendly numbers. You can multiply them in any order and you're gonna get the same product for the same answer. So I'm gonna make friendly numbers. I know that 2 times 5 is 10. And then I'm gonna bring down my 8, and then 8 times 10 is 80. And then don't forget your unit, centimeters. And because we multiplied 1, 2, 3 dimensions, don't forget to cube it. So you have 80 centimeters cubed. Do you see the answer over there? It's there. I hope this video helped you. If not, ask questions. Ask questions until these ideas make sense. Use more than one strategy. We've got you.